So now the question we have to pose to ourselves is, what happens if one of the 3 points that they give us does not include the y-intercept? And that's what's going to happen here on example 2 on page 213 of our book, where it says find the equation of a quadratic function whose graph is a parabola containing the points -1, 9, 2, 6, and 3, 13. As you can see, they did not give us any of the y-intercepts. There was no 0, anything here. So we're going to have to work just a little bit harder to achieve our answer. Now the answer is still the same as we saw in example 1, as in f of x equals ax squared plus bx plus c. And we just need to figure out what's a and b and c. And so for right now, let's go ahead and just remind ourselves here that we're looking for a, we're looking for b, and we're looking for c. Okay, much like we did example number 1 from page 213, we're going to set this up so that we can solve for a, b, and c. We know that if we stick in -1 for x, the answer is going to be 9. We know if we stick in 2 for x, the answer is going to be 6. And if we know we stick in 3 for x, the answer is going to be 13. And this is going to help us achieve what a and b and c are. So let's get those set up here. We're going to have a start of 3 equations. So we're going to have equation number 1. That's going to be a times our x value of -1 squared plus b times our x value of -1 plus c, which we don't know this time, equal to 9. Then we're going to have equation number 2, and that's going to be a times 2 squared from our 2, 6 point here, plus b times 2, plus our c value still, equal to 6. And then finally, we're going to have equation number 3 here, and that's going to be a times the x this time of 3, so 3 squared, plus b times 3, that's our bx, and again, c we don't know, and it once again equals the end here, which in this case is 13, 313. All right, so now we want to go ahead and square and multiply and do that kind of fun stuff here, so we'll do it right next to it here, equation number 1 once again. -1 squared is 1, and 1 times a is a. -1 times b is minus b, and of course c just is hanging out by itself. And finally it equals 9. Equation number 2, similar, except that we have 2 squared to start with. That's going to be 4a this time. 2 times b is 2b. C is still c, and it still equals 6. And then here in equation 3, we're going to have 3 squared, that's 9a. We're going to have 3 times b, 3b, plus c, and it's going to equal 13. All right, so now we have 3 equations here. We have 3 unknowns, so it makes sense. There's an old math adage that says to solve for the number of unknowns, you need that many equations. So since we have 3 things we don't know, a, b, and c, we need 3 equations. And we have 3 equations that are going to do that for us. I need to now eliminate to get rid of one of the variables. I need to use 2 of the 3 equations to do so. So in iteration 1, I'm going to use equations 1 and 2, and I'm going to get rid of c. Then I'm going to use equations 1 and 3, and I'm going to get rid of c. Now it's important in your first iteration that you get rid of the same letter. So you can't get rid of c in the first, between 1 and 2, and then suddenly decide the next one you're going to do 1 and 3 and get rid of b. It doesn't work that way. You've got to eliminate completely one letter with this operation. And so since I think c is the easiest, I don't have to multiply it times any numbers except for -1. I like that. I think that's the option I'm going to go with here. So what I'm going to do is I'm going to use equations 1 and 2. And for 1, I'm going to go ahead and multiply it times -1. So I'm going to put a little -1 there to remind me that -1 times a is minus a. -1 times -b is plus b. -1 times c is minus c. And then don't forget that you also have to take 9 times -1, which is -9. Then now equation number 2, I'm just going to use as is. I'm not going to change anything about it because I've got this elimination set up now. I've got 4a, I've got 2b, I've got plus c, and it equals 6. And I'm going to eliminate from here because the c's are naturally eliminating themselves. So I've got -a plus 4a, that's going to be positive 3a. I've got plus b and plus 2b, that's going to make positive 3b. And then I've got -9 and positive 6, that's going to make a -3 here. All right, we're going to go ahead and call this one equation number 4 so we can keep them straight. We're going to have 5 equations at some point here on this work that we're doing. And so when you number them, it's easier to keep them straight, I think, that way. And I could use a, b, and c, I suppose, but then I might get mixed up with the a, b, and c I'm trying to solve for. So I just call them equation 1, equation 2, equation 3, equation 4, equation 5, and I circle them so I know that's what I'm talking about. So we have equation 4, that's great. we need to get another equation here that says just a and b so we can eliminate the a's and b's. So this time we're going to use 1 and 3. Now you don't have to use 1 and 3. You could use 2 and 3, or you could use, well, I guess that's pretty much it. So it's either 1 and 3 or 2 and 3. It's up to you. I'm going to use 1 again because I have to use that one. I can't use 1 and 2 again. That's the only ones I can't reuse again as far as those two together. So I'm going to use 1 and 3. And once again, I'm going to multiply -1 times my first equation. So again, it's going to be negative a. It's going to be positive b. It's going to be negative c. And once again, it's going to equal -9. Equation number 3, I'm not going to touch that at all. So we're going to have 9a still. We got 3b. We've got plus c. And it still equals 13. And now I'm going to eliminate again. And once again, I'm eliminating the same letter I eliminated the first time up here. When I used 1 and 2, I eliminated to get rid of my c value. I'm doing the same thing here. I'm getting rid of my c value. So I've got negative a and 9a. That's going to make positive 8a. You've got 1b and 3b. That's going to make 4b. Your c's cancel. And you've got -9 and positive 13, which makes positive 4. So let's put down what we got right now, the two equations. I've got equation number 4, which was 3a plus 3b equal to -3. And now I've got equation 5 over here. I should label that. And equation 5 is 8a plus 4b equals 4. Perfect. All right, now, once again, as we look across these things, the top equation, number 4 here, I see 3a, 3b, and 3. Those are all divisible by 3. And on the bottom equation, I see 8a, 4b, and 4. Those are all divisible by 4. So let's go ahead and divide each of those equations by what we can and make them smaller. So in equation 4, we're dividing everything by 3. So that's going to give us positive a, positive b, and -1. And then in equation 5, we're going to have everything divided by 4. So that's going to be 8a divided by 4 is 2a. 4b divided by 4 is just b. And 4 divided by 4, once again, is just 1. And so now we have a plus b equals -1, and 2a plus b equals 1. And so we're going to eliminate one more time. I know, it seems like forever. It seems like a lot of eliminations, but really it's only the third elimination. But we're going to eliminate one more time to get rid of either a or b. And it doesn't matter which one we choose to get rid of. I'm going to get rid of b, I think. And so I'm going to multiply my top equation once again by -1, which should allow me to do that. So again, I'm going to go right here. I'm going to say equation number 4. I'm going to put my little -1 here. Remind myself I'm multiplying it by -1. That's going to give me -a minus b equal to positive 1 now. I still got equation 5. And equation 5, we're not changing anything. It's 2a. It is plus b. And it still equals 1. Now we could say -a plus 2a is just a. The b's eliminate. And 1 plus 1 is 2. And hey, a equals 2. That is terrific. We can come back up here and we can say a equals 2. All right, now I know what you're thinking. You're thinking, wow, we've come a long way, and that was a lot of effort, and we found 1 letter, and we need to find 3 letters, or in our case, 2 more letters. Oh man, I'm not looking forward to the rest of this problem. But here's the good news. It's going to go really quick after this, because all we're going to do is step back 1. We're going to take this a equals 2. We're going to step back 1 into either of these 2 equations, or in fact, either of these 2 equations here, and we're going to use that to figure out what our b value is. In fact, let's use equation number 4 for that. So in equation 4 here, we have a, which we now know is 2, plus b equals -1. If we move the 2 over, we're going to have b is equal to -1 minus 2, otherwise known as -3. And hey, we just solved it that easy, that quickly. So now the last thing we need is c. And to solve for c, we need to go back to one of the original 3 equations, pick either 1 or 2 or 3, it doesn't matter which one, and put in the a that we know 2 and the b that we know -3 to solve for our c. I'm going to use equation 1 because my a and b and c are all there. They're all laid out. I don't have to do anything. So we go up here to equation 1, and we say 2 is our a, minus our b is -3, so we're going to have a minus, plus c equals 9. Well, minus and minus makes plus here, plus 3. 2 plus 3 is 5. So right now we've got 5 plus c equals 9. And then we're going to say that c is equal to 9 minus 5, otherwise known as 4. And so we'll get to come over here and we'll get to say, hey, c is equal to 4. It's a little explosive, c4. And now that we have all three things that we need, the a and the b and the c, we're finally ready to write the final equation up here. And so our final answer is going to be f of x equals, our a is 2, so 2x squared, as in ax squared. Our b is negative 3, so it's going to be minus 3x. There's our bx. And then our c is 4, so it's plus 4. You know, had c been negative 4, we would have put negative 4 here. But because c was a positive value, we're going to keep it a positive value. And so there is our end answer. F of x equals 2x squared minus 3x plus 4. I know it's a lot of work when they don't give you a c value, but it's still elimination and work that I know you can all do. So we'll go ahead and try some of the exercises related to this, and we'll see how it goes.